Okay, in this section 4.6, we're going to be solving radical equations. We're going to look at it from a graphical point of view and also an algebraic point of view. So we talked about this before. So what does it mean to solve an equation graphically? The answer is this question is to look at the equation as a system of equations where the left side of the equation is one function and the right side is another function. So if I look at this from a graphical point of view, this is the left side, that is one function, and the negative one would be another function. And we're going to graph them on the same graph. So if I go to my calculator and I graph the left side, sorry, not get a glare here. So if I type that in as 3 times the square root x plus 2, and you have to push this over to get out of the radical, minus 4. So if I graph that, and then I hit my tab and get the function bar back, and I get negative 1, and I graph that, then what you notice is that I have a point of intersection. And then I can use my calculator to go into menu 6, like we've done numerous times, and find that point of intersection on the calculator. Move to the left of that point. Select, that's lower bound. Now move across. Once the dot appears, you can hit select again, and there is my answer. We can see clearly that the answer is going to be at negative 1, 1. So that tells me that the solution to this, the value of x that makes this true, is going to be when x is negative 1. So this is how we do the graphical approach to things. Okay, so that's what I want you to be able to do. You can also do that on Desmos, but you'll have to draw the pictures too. So don't just assume that you don't have to. So let's go over here and let's do this together. Okay, so we have the graph that we're going to follow. We can see clearly what's going on. We've done this numerous times. The number that makes that 0 is negative 2. So I know I have a negative 2 in here. And it's going to be at negative 2 and negative 4. Remember we talked about that? Whatever makes that 0 is the x value for the start point, and that's the up and down. So at negative 2, negative 4, that's the start. We know we have a dot here at 1, negative 1, negative 1. And we can do the trace feature, and we can find other points in here. Just save some time. And 5, let's do the trace. And we can go 0, don't really care about. What's 1? 2. 2 goes to 2. And let's see, we got 3, 4. 3 won't do anything. 4 won't do anything. 5 doesn't either. Okay, so that's pretty much what we have. And you can kind of eyeball this one at 3 points. So it's almost 4, so right about there. Just to get a place to draw this line to. This is the point right here is negative 2, negative 4. This is the point, and then we have a dotted line or a line that goes right here. And so that point of intersection is the solution point. Okay, so we know that the answer is at negative 1. This is y equals 3, the square root of x plus 2 minus 4, and this is y equals negative 1. Okay, and there's my solution. Algebraically, though, what do I need to do? How do I solve this? Okay, what is the guides I need to follow? Let's do some guidelines here. And I'll show you what I had written out over here. So the guidelines is basically this, and I'll talk about it, and then I'll show you how to let you see it in the video. So the first thing I want to do is I notice I have a radical symbol, and I need to isolate that. So that means I need to get this, just this, by itself, and everything else on the other side. So think about this as solving an equation. So I need to add the 4, and I'll get 3 times the square root of x plus 2 equals 3. Then I need to divide by 3 on both sides. And now I have the square root of x plus 2 equals 1. That's where I need it to be. Once I have it isolated, then I'm going to raise both sides of this equation to the same power, and that's the power that will undo the square root. So for a square root, the power is 2. You have to do it to both sides. You can only do it when this is isolated. Okay? So squaring a square root just gives me the quantity that's left on the inside. And right here, squaring a 1, solve for x, and I get x equals -1, confirming what we knew the answer to be. Now, you need to make sure that if you don't do the graphical approach to confirm, you need to make sure that you check this to make sure that it's not an extraneous solution. Because when we squared this, we introduced another solution, possibly, that could give us another answer. So we plug the -1 back in here, and making sure that I don't get a negative under the radical. Although you should check it all the way through just to make sure. Sometimes you'll plug a number in, it's not negative under here, and it's still not equal to each other. So always check your solutions all the time. Okay, so here's the notes that I have written out here that I want you to look at for guidelines for graphing and guidelines for solving. Okay, notice in here, isolate the radical, but if I have more than one, then I need to isolate only one of them and move the other to the opposite side. Okay, and then raise both sides to the appropriate power, solve. If I have more than one radical after I raise it to the power, then I keep going until I have no radicals left. Always check to make sure your solutions are true, that they are not extraneous. And this is how this works. Okay, so let's look at another example with a cube root right here. So let's look at the graphical approach first to see how many answers I might have. Let's create a new document page, graph. Same thing. This side gets one function, that side gets the other. So I'm going to graph 2, and then I need to do the cube root. Cube root is the button right next to it, right there. And that's a cube, and it's x minus 2. So that is the one function. And then I'm going to graph another one, which is 2x minus 4. There. And notice what I see. I can see that I'm actually going to get 1, 2, 3. Oops, you can't see. 1, 2, 3 solutions from this picture. And I can draw this all out and get some values in here. Let me just go ahead and do that real quickly here to transfer this over to here. You just graph everything according to what you know. This graph right here is very simple. Slope of 2, y-intercept of 4. Okay, so I have a dot here, and then a slope of 2, which means I go up 2 over 1, up 2 over 1, and I can just keep on doing that all the way. And then I can draw that line. Be careful, just be nice and neat as much as possible. Okay, so there's that line. And then we need to graph the radical over here. The number that makes that 0 is 2, so I have a dot here at 2 and 0. I have another dot at 3 and 2, and another dot down here at 1 and -2. And the rest of the dots are going to be off our screen. So it's going to come in over here, flattens out, and then curves off in this direction over here. Okay? And so you can see that I have these values right here, 2 and 0, and this one is 3 and 2. My 3 solutions. So the solutions are x equals 1, 2, and 3. Those are going to be the solutions when we solve this algebraically. Okay, so let's go solve this algebraically. Show you how to do it without having to graph, because kind of made it look like it was very easy and quick to graph. It takes a little bit of time to graph properly. I had the calculator help me out, and I already have the solution written out, so made it a little bit quicker for me. So let's solve this. So we have 2, the cube root, x minus 2 equals 2x minus 4. So I need to isolate. So I'm going to divide both sides by 2. And you'll notice that you can simplify this, so do so. X minus 2. And then this 2 divides into both of those and gives me x minus 2. Remember, you don't just cancel one of them. It's basically you factor out a 2 at the top and it reduces. That's what you're doing. So this is a cube root. I need to undo that. So I have to raise both sides to the 3rd power. This side over here becomes simply x minus 2. But this side is, remember, that to the 3rd power means x minus 2 times x minus 2 times x minus 2. So you have to do that product, okay? And here's how it works. And you can just do that on the side, but here's what you'll end up with. You'll get x to the third, you get minus 6x squared, 12x minus 8. Okay? And so then you want to bring it as a polynomial, so you bring everything to one side, set it equal to 0. By doing that, you end up with this right here. I put it on the left side and changed all the signs appropriately. So if you understand what I've done here, just subtract this, add that to both sides, it'll be equal to 0, and this is what you're going to have. And then we need to use our polynomial techniques to factor this, okay? And so you can then do what we did before in the past with the possible rational zeros. You have to go through that process. You can graph, use a graphing technique, graph this and find, remember, because you haven't done this, type this in the calculator, see where it crosses the x-axis. When you have that, you can do synthetic division. Remember synthetic division, so we know that 1, it might be a choice. This is 1, negative 6, 11, negative 6. 1 times 1 is 1. This is negative 5. This is negative 5. Subtract this gives me a 6. And sure enough, we have it. See that? And then we looked at it on the calculator. We saw another possible rational zero was at 2. Okay? So we keep going. This is a negative 3. This is negative 6. Sure enough. And then we already know this is the last factor. And we can see clearly that 3 is going to be the other choice. And so there's my 3 solutions right there. And we know they're true from the graphing technique we did over here. So once again, we have x equals 1, 2, and 3. So when you're doing with multiple powers like this, just make sure that you do careful with your multiplication and then your synthetic division. Okay? And some later problems that we'll do, let me point out a couple things. Here we have an example where there's 2 radicals. This one is already isolated, so you just simply need to remove this radical symbol first. Okay? And then let's go ahead and do this one and show you how this lays out. So let's get a piece of paper here. I'll take it through a couple of steps. We had this problem right here. Let me just write it out again. Minus 8 plus 1, x plus 5. This one's already isolated, so we don't need to isolate anymore. If you had more than one, you need to have them on different sides of the equation, which they already are. I'm going to raise this side to the squared and this side. Notice it's the whole side. And the reason why I'm talking about this one is I want you to see what happens. See, there's 2 terms here. This means the square root of 3x minus 8 plus 1 times the square root of 3x minus 8 plus 1. I need to multiply that out. This will simply be x plus 5. When I multiply that, the square root is the squared, so these drop out as 3x minus 8. You should leave it in the parentheses like that. That is going to be plus the square root. You wanted to put plus, which is a minus. And then this one right here is another one. Let's see. Again, minus 8. And then 1 times 1 is 1. So that's where I have this now. These can combine into 2 of those. So I have 2 square roots. And then this stuff and that stuff can combine and become 3x and then minus 7. And so now I have 1 radical. And so I want to move everything to one side and isolate this radical. So we'll add the 7 and we'll subtract the 3x. Subtract the 3x and add the 7. We'll leave the 2 for now. Over here I'll get negative 2 plus 12. I'll get 2x plus 12. Divide everything by 2. And now you can see that I've isolated this. So it takes some time here. This becomes a negative x plus 6. And so now I'm at the point where I can square both sides again. 3x minus 8. Then we want to square this thing. So again, you can go off to the side and you can multiply these out as needed. Okay, so you'll end up with a positive x squared minus 6x plus 36. and you need to bring everything to one side and start combining like terms. So subtract the 3x and add the 8. Subtract the 3x and add an 8. 0 equals x squared. Negative 6, negative 6, negative 3. That's negative 12, negative 15x. And this plus that looks like 44. Okay? So we need to find numbers that multiply and give me 44 and add and give me 15. Hopefully you saw that very quickly. That's 4 and 11, and they're both going to be minuses. That means x could be a 4 or x could be an 11. Okay? That doesn't mean those are. Got to check them. Extraneous solution. A lot of work went on for this thing. So we take this number 4, we go over here, we plug it in. So I'm going to get the square root. If I plug in a 4, that's going to be 12 minus 8. And this is going to be 4 plus 5. 12 minus 8 is a 4. This is a 2 plus 1 is 3, so this is a 3. This is 9. And sure enough, that is a solution. Let's try the 11. If I plug in the 11, I'm going to get 33 minus 8 plus 1. 11 plus 5. 33 minus 8 is 25. So this is the square root of 25 plus 1. This over here is the square root of 16. The square root of 5 is 5. 25 is 5 plus 1. This is a 4. Nope. Didn't work. This one is not a solution. Only that one is. And that's how you deal with it. This was extraneous. This is the only solution. So you only circle that solution right there. So you see some of these can get kind of involved. Just take your time, work through them, and you'll be okay. And that ends this video.